What are the differences between discrete and continuous data? Remember that this section is for the title of your notes at the very top should be relations, and that's in the left-hand column of your outline. And we're going to discuss the differences between discrete and continuous data. Okay, here's a reminder of how your notes should be set up. Your section and title go up top. The video title, which is this video title, goes in the left-hand column. There is no video title 2 or 3 for these notes. You'll write your notes, review your notes and the question, and then you're going to go ahead and create your summary, which should be 3 to 4 sentences in length. Let's begin our lesson by discussing what discrete data is. Discrete data is a type of data that can be represented on a number line or graph with only integers. So I'm going to be highlighting and underlining keywords like for discrete data, it's only integers that could be represented. And integers would go from negative values like -3, -2, -1, zeros included, and then 1, 2, and 3, and so on and so forth. So any negative or positive number. For example, a 5-question quiz is given in a math class. The number of correct answers on a student's quiz is an example of discrete data. The number of correct answers would be 0, right? I said 0 could be a possibility, 1, 2, or 3. If you put this on a number line, you would not include anything in between them for this data set. So you would not include, you can't get half, well, technically you could get half an answer right, but if you did, then you still get that question incorrect. So the possible number of correct answers can only be represented by whole numbers or by integers, 0, 1, 2, or 3. Let's talk about then discrete graphs. Discrete graph, a graph that consists of isolated points. So these points are all isolated, which means I do not connect them. So if I did this, if I connected these dots to create this line, that would not represent discrete data because we're not including the values in between those points. We're only including the whole numbers. That's it. Only the integers. I keep saying whole numbers, but it's really integers. It's the counting numbers, and it could be the negative numbers or positive numbers. But this, you cannot connect to create a line. It's just going to be a whole bunch of isolated points for a discrete graph. Okay, now let's talk about continuous data. So I just want to review what we just discussed. Discrete data was isolated points and integers. Continuous data makes up the rest of the real world data types. So this is one of the most common types of data. And it's very common because we always graph lines. This type is usually associated with some sort of measurement. So it could be height or temperature, weight. Ask yourself, is it possible for the data to take on values that could be any fraction or decimal? If it could take on any fraction or decimal, then it won't be discrete. It has to be continuous. So let me give you an example. The length of time it takes for a light bulb to burn out. Could it take 80 hours, 80.7 hours, or 80.789 hours? So remember that it's not that a light bulb will go out at 1 o'clock or 2 o'clock. It goes in between those times. So that is a continuous type of data. And I want to also underline that this can be a fraction or decimal. Okay, you should be very used to seeing continuous graphs. Continuous graph is a graph that is unbroken. Notice that it has a continuous line. What some people mention it as is if you can draw the line without having to pick up your pencil, then it's continuous. So this is unbroken. Notice that they're not isolated points, that they're continuous points. So these values include fractions and decimals, and negative and positive numbers. So just to review what we just learned, remember that a discrete graph or discrete data is the integers, so negative numbers, 0, or positive numbers. And continuous data or continuous graph is all those numbers in between, including the integers as well. So it could be any negative or positive number or 0, but it also includes the fractions or decimals. Okay, let's test your knowledge and see if you can decide between these different scenarios whether they are continuous or discrete. Because this is what you're going to have to do do a lot, not just with continuous or discrete. You'll also have to compare graphs for exponential or linear functions. And we'll be talking about that over the next few weeks. But before we get into it, let's discuss this continuous or discrete. So take a look at problems 1 through 5, write them down, and then I want you to decide which ones are continuous or discrete. Once you've done that, then you're going to go ahead and push play on the video, and then you can watch to see if your answers are correct. So go ahead and write this down, pause the video right now, and try them on your own. Okay, let's go ahead and reveal the answers to see if you're correct. Number 1, the number of times it takes a person to pass a written exam to obtain a driver's license. So they can't take it 1.5 times or 2.5 times and be able to pass it. So it should be, oh no, my eraser's not working. Okay. Oh, okay, it's going to show all answers right now. I tried to erase them one by one, but it won't work. There you go. Here are the answers. So number 1 should be discrete. Number 2, the height of a tree at a nursery. Well, the height of a tree can be fractions or decimals. Height, it could be 1 foot and 3/4 of an inch. So this is going to be continuous. The number of suitcases lost by an airline. Okay, well, they can't lose 1.5 suitcase. That'd be weird. It's like cutting a suitcase in half. So that's going to be discrete. Number 4, here is a line, and you can graph that line and create that line, and it seems continuous. However, the domain is all these x values. It's not, notice none of them are fractions or decimals. So if I plug in these x values, I will get y as a whole number as well. So this is going to be discrete data. They're going to be isolated points. And in this case, the domain x is greater than 0, so all values where x is greater than 0, that includes negative numbers, or excuse me, that does not include negative numbers because x being greater than 0 is positive. That includes fractions and decimals is what I wanted to say. So this is going to be continuous. Okay, here are 5 other examples for you to try on your own, but I just realized that number 1 is exactly like one of the problems from the last slide. So ignore that one or test yourself again and see if you get the correct answer. I'm not going to reveal the answer for these ones. Instead, we're going to discuss them in class, but this is just an opportunity for you to do some independent practice. And now I'm going to bring something new into the video. What are the differences? Oops, did not mean to move that. What are the differences between discrete and continuous data? Now that you've watch the video, you've written down notes, you practiced some examples, and you also have absorbed all of this new knowledge, I want you to now apply it. So answer this question. What are the differences between discrete and continuous data? So you can say, well, the difference is discrete data is this, or continuous data is this. Okay, so there are some sentence starters to help you out. Go ahead and answer those questions. And when you answer this question, that goes in your summary.